So in this video, I will be introducing the normal distribution. So I will first talk about the concept, and then later I will have down in the description the time at which I start to do past IB exam question with an explanation as well. So starting with the normal distribution. So you might have seen a graph like this. This graph represents the normal distribution. So there are some characteristics of it that I will be pointing out because this is like one of the most important concepts in probability. So first of all, as you can see, this curve is called also like a bell curve. It is completely symmetrical. So what you can tell from it is that, like, for example, the left side here is completely the exact same thing as the right side. And in the middle, the line that passes exactly in the middle and touches the tip of the bell is actually the mean. So you can label it as the mean. This letter, mu, is the one that describes the mean. And because of this symmetrical property that it has, you could also define this top as the mode and also as the median. So this is quite useful because it kind of just merges them all in at once. So you may have seen before that those curves for probability to, like, for example, if you want to find the probability of somebody being 1 meter 70, then you would just trace it up and then find the equivalent point on the graph, and then you would find the probability. But this is not how this curve works. It doesn't work by single values, but it works with ranges. So for example, from this graph, you'd be able to find the probability, for example, of being between 1 meter 65 and 1 meter 170. And how it does it is that it doesn't find the points on the graph itself, but it calculates the whole area. You may have seen it already or not if you follow the IB program. This concept is called calculus. If you haven't, you don't have to worry about it now, but it's basically a mathematical way of finding areas under a curve. So the next important concept is standard deviation. So standard deviation, there's a definition for it right there, which is that it is the measure of spread from the mean. So for example, if you have a sample of people and their mean heights here would be 1 meter 67, the standard deviation is basically saying how far apart is everybody's height away from the mean, like from the average. So if I tell you that the standard deviation, for example, is quite low, it means that people are quite closely are close to the mean, which means that the spread is really low. So people are on average have quite a similar height, which would be here like 1 meter 67, sorry. Whereas if I tell you that the standard deviation is high, it would mean that the spread is a lot more. So it means that like there's more values that are away from the mean as if you had a low standard deviation. So if you have seen this word variance with this sign, the symbol, which is sigma but to the power of 2, it's basically the square of standard deviation. Because I know that in binomial distribution you might have seen variance before. But so this one is standard deviation, this one is variance. They basically mean the same thing. It's just a different way of interpreting this measure of spread. So for standard deviation, there is actually this equation which defines it. Honestly, for the IB, you do not need to use it. So it's just in case you come across it, so you don't get confused or something, because it looks like a lot, and just don't worry so much about it, because also like the calculator can do all the work for you, so you don't really need to know this equation, but just in case you come across it. So something important is the way you would, so here, for example, like I mentioned earlier, the way that you would write this the probability that's between 1 meter 64 and 170 is like this, because you know that P stands for probability, X is of your random variable that you're using, so for here it would be the height that we're measuring, and then you say that it's between 1 meter 64 and 170. So this is the way you would write it. And then I want to show you how the graph would change depending on, oops, there, sorry, how it would change whether you change the standard deviation or mean. So this is, gosh, so this is the equation for a normal distribution. So this is the x that we saw earlier, this one, which is of your random variable, and then this n stands for normal distribution. Then, as we saw earlier, this is the sign which shows mean, like we had here. This shows the mean, and this one shows variance. So it's in terms of variance. But however, something you need to keep in mind is that it's always written like this, which actually means that you plug in the value of the standard deviation. So they won't ever, like, it would be rare that they give you the variance. They would much rather give you the standard deviation. So for clarity, usually they write it out like this, so they would just plug in a number and have it to the power of 2. So with this in mind, here for example, this graph, you can see that they tell you that the mean is of 2. So you can see here that the middle of the graph is on 2. And then they tell you that the standard deviation, like see, that's what I mentioned earlier, like they put the standard deviation and then to the power of 2. So they would tell you here the standard deviation is of 0.4. If you have this graph, there, this one has the exact same mean of 2, but then it tells you that the standard deviation is 1.2. So you can see that it's higher of a standard deviation, and this is why the graph stretched out, because like I told you, standard deviation is the spread, so it'll spread out more from the mean, where like compared to this one. And then even more extreme, you could see on this graph right here that the standard deviation is of 2.2, which is even higher, and again the graph just spreads even more. Also, something to mention is that the area, the total area that's under the graph, is actually equal to the total probability of your event that you're, like your event x that you're calculating. So for instance, it would be equal to 100%. Or as you may have seen in probability, we don't use percentages, but we use decimals. So it would mean that the entire area under the curve is equal to 1. And this works for every single graph that you will ever come across, no matter the shape. Like I just showed you, no matter what, it will always be 1. And then these graphs, they will show you how it changes depending on the mean. So here you can see that the standard deviation is of 0.7, but then the mean is 5. So you can see it clearly here because the halfway point on the top is exactly on 5. On this graph, it tells you that the mean is negative 3.5, so it can go in the negatives, but standard deviation doesn't go into the negatives because just it doesn't make sense to have like a spread that's negative that goes, like it would cancel out, it wouldn't work. So it's always positive, but the mean can be negative. That's why you can see it goes onto the negative side. And then for this one, you can see the mean is 2. That's the same example we had earlier. So you can see that it shifts, but it doesn't change the shape of it. It just shifts along the graph. Okay. So next, I will show you some characteristics of the normal distribution, which are quite important. And this actually works also for biology. When you have to identify graphs or like interpret graphs, this is actually something that comes up sometimes in paper 1 multiple choice questions, just so you know. So what this is basically is it's the same graph as before, sort of, where like the middle here is u, this mu letter, which means the mean, so you can see it's in the middle. And then on each side, you can see that actually it says that it's the mean plus 1 standard deviation. And then on the other side, it's the same thing. So it's the mean minus 1 standard deviation to the left. So this is plus on the positive side and then negative. And what this is saying actually is that 0.68, which means that 68% of your values will be within 1 standard deviation from your mean. This is something to remember. It is very useful to know. And there's a lot of questions that will give you this percentage, and they won't tell you what it is exactly, but they'll tell you this percentage, and then you have to know right away, oh, right, this means that it is 1 standard deviation away. So there's this one to understand, and then there's also quite an interesting one for 2 standard deviations away from the mean, which is that 95% or 0.95 of your values will be within the mean and 2 standard deviations on each side. And then finally, 3 standard deviations away, you have 0.997% of it, which is within 3 standard deviations, which is most of it. So I'll go and use an example to show this concept. So this is the same type of equation, like same type of question that you could get on the EIB. This is just a practice though. So they tell you that X represents a catch of fish which has a mean weight of 1.8 kilograms and a standard deviation of 0.5 kilograms, such that this, and this is like, remember this equation that I mentioned? So you know from it that they told you the mean is 1.8, that's why they plugged it in here. And then they tell you that the standard deviation is 0.5, they put it here, and then they squared it. So they leave it in this form because this is the form that is most useful. And then they tell you, find the interval centered around the mean that contains the weights of approximately 68% of the fish. So this is where you find that the graph that I mentioned earlier is quite important, this one. Because now they're not telling you what the interval is, so they're not telling you what these limits are, but they tell you that they know what the overall like area here is, which is 68%. So by telling you this, you will know right away that because it is 68%, you know that it's 1 standard deviation away from the mean. And you already have the mean and you have the standard deviation, right? So the way to show this is like that. So if you take 1.8 and you minus 0.5, so 1.8 is your mean, minus 0.5, which is your standard deviation, you'll get one standard deviation away. And then on the other side, you will do plus 0.5 right here, and then it will give you the other interval. So if you do that, you'll get 1.3 and 2.3. And that, you know, is equal to the 68%. So that's why this 68% and these graphs are quite useful, because they come up in questions like quite often. So now I will be doing a past IB question for practice. So you can see this question right here. So you can tell here it's just a screenshot. It's from the exam from May 2017. This is a paper 1 question. And it would figure around like in the easier questions, because this one you don't really need to use any equation in the calculator or something. It's just from your knowledge of what this curve means basically. So let's see for number 1, for example. So they tell you that the random variable x is normally distributed. So right away you know that this curve is symmetrical. That's what they're telling you, because the graphs aren't usually, or like images in the IB aren't like to scale, but this one, because they tell you it's normally distributed, so you know that it will be symmetrical along the mean, which is the middle. So they tell you with a mean of 100. So right away, oops, it is quite easy, quite useful to like draw out what they're saying because it makes it more visual and it's easier to understand. So right there, they tell you that the mean is 100. So you know that right in the middle, it'll be 100. So the following diagram shows the normal curve for x. Great. So now they tell you, let R, so here R, be the shaded region under the curve to the right of 107. And then they tell you the area of R is 0.24. So it's basically telling you that the probability of anything above 107 will be R, which is 0.27, 0.24, sorry. So let's go to the first question. They say write down. So here you have to understand this notation. It means that the probability of your event X is larger than 107. So actually, you already know this, right? Because they tell you in the question that the probability of anything above 107 is R, right? So when you write out your answer, also something really important for the IB is to write everything that you do because they give you points not for your answer necessarily. Like they'll give 1 point, for example, for your exam for your answer, but what's most important is your working. So every time show everything that you do. So for this one they just say write down, so you know that it will be, and also it's 1 point, right? So you can see that it'll just be stating the answer. Because anyways, you don't have to do anything about it, you just have to find it. So you write out that the probability of x being bigger than 107 is 0.24. This is because I already gave it to you. So now let's go for question 2, B. So they tell you, find the probability that x is in between 100 and 107. So that one's trickier. They're telling you, so you can look back at the curve, and so they're telling you x is bigger than 100. So on the curve here, you know that it will be here somewhere on this half, but it has to be lower than 107. So you can tell from the graph that it will be this area right here. So between 100 and 107. So what do we know about this curve that will help us to solve it? So first of all, okay, so that's the question. We know, remember that I told you that the curve is completely symmetrical about the mean, which means that this side is equal to this side. And I also told you that the total area under this curve will always be 100%, or 1 in terms of decimals. So if you consider the fact that it's symmetrical around the 100, you know that 50% will be on the left and 50% will be on the right. So in terms of decimals, you can write that as 0.5 will be on this side and 0.5 will be on the other side. So this helps you because now you're able to know that the probability of your event being bigger than 100 is 0.5. So this you can just tell because you know that it's normally distributed and symmetrical. So then, what else do you know? You already know what this area right here, R, is, because that was the first question, right? So then, all you need to do is find the difference between this whole area minus this R area, because you don't want this one. And the way to write it out would be like this, which is the probability of something being bigger than 100, which is this whole area, minus the probability of your event being bigger than 107, which is your R here. And this will leave you out your answer, so right here, between 100 and 107. So you already know the value of bigger than 100 is 0.5, and then you know the value of bigger than 107 because that is your like the value that they already gave you. If you take the difference then on your calculator, you can find that this area from 100 to 107 is 0.26. So this tells you that 26% of your data will be between those 2 points. So now let's move on to question 3. So C. So now they ask you, find the probability that your x is between 93 and 107. So this one's tricky because we don't know anything about 93. But then think about what the difference is from 100 to 107. The difference in value is 7, right? So and then think about 93. 93 to 100 is also 7. So if you write out on your graph what you're looking for, right there, 93, you can actually notice that because this is only because it's symmetrical. Because this value from 100 to 107 is the same difference from 93 to 100, then you know that these two areas will be equal to each other. So this is quite useful. This is why the symmetrical characteristic of this curve is very important. So your question is this, so the probability between those 2 points. And you already know what between 100 and 107 is, right? Because we just found it here. It's 0.26. And because, like I just said, you know that it's also equals to the probability between 93 to 100, because these two are equal to the same thing. So you know that this part here is equal to this part, and because you already know it, you can just times it by 2, because it's just the same thing twice. So the value that you had earlier, 0.26, you times it by 2 and you get 0.52. So for your answer, this one, it tells you that all the values between 93 and 107, there's 52% of them that are between these two values. So in the next video, I will post some harder questions about the normal distribution with an explanation for each.